Alright, so let's take a look at the first example. Should be very straightforward. You don't have to find the antiderivative already. Right? So now it's just the job for you to evaluate the antiderivative at the limit of integrations. Okay. So example, evaluate the integral from 1 to 3 of e to the x dx. Now, what is the antiderivative of e to the x? It's just e to the x, right? So it's different from the general antiderivative that we did before. We usually, for the general antiderivative, usually had the plus c at the end, right? But for the definite integral, because remember, definite integral is used to evaluate the area under the curve, right? You should get a constant. So therefore, you don't need to include plus c for the definite integral. So e to the x is the antiderivative of e to the x. Now you evaluate that at 1 and 3. So you get e to the third power minus e to the first power. And then you get the answer. That's the answer. Next example, find the area under the parabola y equal to x squared from 0 to 1. When you are asked to evaluate the area under a certain curve, that means you have to set up a definite integral. So this is equal to the indefinite integral from 0 to 1 of x squared dx. Right? So the curve that you want to evaluate is x squared. What is the antiderivative of x squared? 1/3 times x to the third power. And now you evaluate this functions or this antiderivative at 0 and 1. Okay, so this gives me 1/3 times, so you can put, so 1/3 is the constant multiple, so you can leave it outside. And you evaluate x cubed at 1 and at 0. So you have 1 to the third power minus 0 to the third power. Or the answer is 1/3. The next problem, I'd like you to evaluate definite integral from 3 to 6 of 1 over x dx. So for this integral, what is the antiderivative of 1 over x? It's ln of absolute value of x. So if you evaluate this at 3 and 6, you get ln of absolute value of 6 minus ln of absolute value of 3. But 6 and 3 are positive constants, so you can drop the absolute value. So you have ln of 6 minus ln of 3. So let me move on to the next example. Can you compute this integral x plus x squared dx for x is going from 0 to 1? Remember, the integral of the sum is the sum of the integral. So the problem can be written as is equal to the integral from 0 to 1 of x dx plus the integral from 0 to 1 of x squared dx. What is the antiderivative of x? 1/2 x squared. And you evaluate at 0 and 1. What is the antiderivative of x squared? 1/3 x cubed. Evaluate at 0 and 1. Right? So 1/2 is the constant multiple, just leave it like that. And you evaluate x squared at 1 and at 0, so you have 1 squared minus 0 squared plus 1/3 times 1 to the third power minus 0 to the third power. And therefore, you get 1/2 plus 1/3. This comes down to be 5 over 6 for the answer. Example, evaluate the integral from 0 to 3 of x cubed minus 6x dx. So once again, the integral of the sum is the sum of the integral, or the integral of the difference is difference of integrals. So the original problem can be written as the integral from 0 to 3 of x cubed dx minus the integral from 0 to 3 of 6x dx. Remember, the 6 is the constant multiple, so you can pull it out of the integral operations. So you get this is the integral from 0 to 3 of x cubed dx minus 6 times the integral from 0 to 3 of x dx. And the integral or the antiderivative of x cubed is 1/4 x to the 4th, evaluate at 0 and 3, minus 6, which is the constant multiple, times 1/2 x squared. 1/2 x squared is the antiderivative of x. You evaluate this at 0 and 3. So now you can evaluate the functions, right? Have 1/4 times 3 to the 4th minus 0 to the 4th. minus 6 times 1/2. 6 times 1/2 is 3. And you get 3 times 3 square minus 0 square. Can simplify, and you get 3 to the 4th power minus 3 times 3 square. 3 to the 4th power is 81. So you have 81 over 4 minus 3 times 3 square, which is 27. The next example is a little bit different than what we have seen so far. I'd like you to compute definite integral from 0 to 1 of u plus 4 times 2u plus 1 du. Right. So by looking at this integrand, you see that this is not the standard integrand that you see so far. Right? There's no special formula that you can use. So it's not exponential function. It's not 1 over x. Right? It's not sine function or cosine functions for that matter. It's not. You cannot use power rule for antiderivative right away. So by looking at this problem, tell me what is the first step that I should do here. You follow the binomial and see what happened, right? So usually you have this factors multiplied together, expand them. So this is equal to the integral from 0 to 1 of 2u squared plus u plus 8u plus 4 du. This is equal to the integral from 0 to 1 of 2u squared plus 9u plus 4 du. So we expand, and then expand the factors, and then you combine like terms. And now the integral of the sum is the sum of the integral. So you can write this is the integral from 0 to 1 of 2 times u squared du plus the integral from 0 to 1 of 9u du plus the integral from 0 to 1 of 4 du. Remember, if there is a constant in front, that is the constant multiple, you can pull the constant multiple out of the integral operations. You got 2 times the integral from 0 to 1 of u squared du plus 9 times the integral from 0 to 1 of u du plus 4 times the integral from 0 to 1 of du. So the antiderivative of u squared is 1/3 u cubed, evaluate at 0 and 1. The antiderivative of u is 1/2 u squared, evaluate at 0 and 1, plus 4u. Right? So the antiderivative of 1, so in this case, if you just see the integral of, or the antiderivative of nothing here, which is 1 du. So the antiderivative of 1 is equal to u. You evaluate this at 0 and 1. Well, you got 2/3 times 1 cube minus 0 cube plus 9/2 times 1 square minus 0 square plus 4 times 1 minus 0. So what do you get? You get 2/3 plus 9/2 plus 4. You can leave it like this, or if you want to spend extra time to evaluate this number, please feel free to do so. 55 over 6